Hello boys and girls, my name is Madam Yap and today we're going to learn how to do an experiment. Okay, for a scientist, imagine if a scientist were to look at these origami frogs, he may have a question. I wonder which frog will travel the furthest if I blow at it. Like, okay? So, what he does first is he converts his question into a statement and we call that a hypothesis. So the question is, which frog will travel the furthest when it is blown? So he converts it to a statement. So which one do you think will travel the furthest when it is blown? A very lightweight newspaper frog, a writing paper frog, or a drawing block frog, which you can actually feel is heavier than all the rest. So the scientist may think, I think the lightest frog will travel the furthest distance when I blow at it, like blow at it, right? So he will make a statement. The lightest frog will travel the furthest distance when blown, right? So that becomes his hypothesis. Then he has to start the experiment. Now when he starts the experiment, he actually has to plan. Okay, like for example, like, okay, we're kind of ready to start. I see some of you are a little bit concerned. What's wrong with starting the experiment? The little frog is too little. Okay, some of you are saying it's not fair. Like when you want to fight, you must pick someone your own size, right? Yeah, it's true, it's not fair. Okay, so maybe we get a bigger frog. What do you think? Okay, I got a bigger frog. Well, it's kind of bigger, but it's not exactly the same size. Will this do? It's bigger. No, you're saying it's not a good idea? Okay, how about this one? Exactly the same size. Okay, alright. So we should get the same size because otherwise it is not fair, right? This one is too big, too small, not fair. Then, okay, if I were to start the experiment, okay, alright, maybe they all are ready. Okay, so hang on. My starting line is here, but they're all at different positions. So it is still not fair, right? You'll say it's not fair because this one is so far ahead. This one might win. Okay, alright, so we should all make them start at the same starting point. Whoops. Okay, so which is all here. Okay, make sure they're all at the same starting point. Okay, so we're ready to start. Then, hang on, but what if I, blow very hard for one of them? And then this one, I just blow very lightly. Not using the same strength. Do you think that's fair? It's not fair, right? So I have to remember there are three variables that I need to keep the same, which is same size of the frogs, same starting point, and also use the same strength to blow the frogs. Okay? Alright. Then, and you can see in this experiment, there's only one thing that we change. So do you know what is the variable or what is the condition that we change? The rest we keep the same, but one thing is changed. It's the material of the frogs. And the material of the frogs will mean that these three frogs, same size, will have different mass. They weigh different, okay? So, only one thing is changed, which is the mass of the frog, or the material. And then, we are ready to start our experiment. In your worksheets, you may want to write down the variables to keep constant are the size of the frogs, the starting point for the frog jumps, and the strength of the breaths to blow the frogs. So there's only one variable we change, only one, and that is the mass of the frogs, or how heavy they weigh. Because we use different materials to make the frogs. So if you're ready, we can start. So I make sure that my frogs are all at the same starting point. Okay. And I'll blow. Okay, so my starting point is here, right? I'm going to use a measuring tape to measure the distance that the 3 frogs traveled, and you can see that there are 2 measurements. The first one is on one side of the measuring tape, it says centimeters. On the other side, it says inch. So we'll use the centimeter one, okay? Centimeter. So we take, starting from 0, we put 0 at the starting point, and then we measure. So this frog moved 43 centimeters. This frog moved here 20 centimeters, and this frog moved 3 centimeters. Alright, so let's write down the results. So the newspaper frog moved 43 centimeters. The second one was 20 centimeters. The third one was 3 centimeters. And if you turn to the next page, there is a bar chart that you can draw to represent your results, because when you draw your results on a graph, it helps you to see and analyze better, to understand the results better. So I'll get a ruler. Newspaper is 43. So can you see where 40 is and 45? Right in the middle is 45. So 43, we will just draw a little bit lower than 45. Okay, so about here. So this is your newspaper frog. Writing paper frog was 20 centimeters. So you see where 20 centimeters is? So you draw a bar graph. And then lastly, the drawing block frog was 3 centimeters. So right in the middle of these 2 lines is 5. So take a little bit lower than that, which is here. So draw your drawing block frog results. And so you have got a bar chart. So it's the newspaper frog that traveled the furthest distance, the writing paper frog not so far, and the drawing block paper frog traveled the least distance. So is your hypothesis correct? Let's check our hypothesis. Our hypothesis says the lightest frog will travel the furthest when blown. So which was the lightest frog? It was our newspaper frog. So this newspaper frog was the lightest, and the drawing block frog was the heaviest. So is it true that the lightest frog traveled the furthest distance? It's true. Okay, and then this one is in between the mass, and the drawing block frog was the heaviest, so it traveled the least distance when blown. So our hypothesis is correct, yes. And so we are done with our first experiment. Okay, so we have a question to test you to see if you know how to read bar graphs, bar charts. Alright, so here we have a question. Yan Qi investigated how different types of exercise affected her pulse rate. Now, how do you measure your pulse rate? It's a number. It represents your heart rate. So if you put your finger on your pulse like this, they can feel a little throbbing at about this part where your vein is, or your blood vessels, your artery is, and then you can feel a little pulse. So after you exercise very vigorously, like running, then you'll feel that your veins will, or your artery will throb harder. Okay, your blood vessel will throb harder, and you can feel your pulse also going very fast. Whereas if you're resting, then your pulse rate is slower. So pulse rate is measured in beats per minute. Yan Qi recorded her pulse rate at rest. That means she's just resting. And 10 minutes after she had exercised in different ways. So this is her pulse rate at rest, and she did some other exercises. And this bar chart shows the pulse rates when she does the various exercises. So at rest, we can see that her pulse rate is between 60 and 80. So in between, it is 70. Okay? Right. So the question is, which type of exercise exactly doubled Yan Qi's pulse rate at rest? So at rest, it shows a pulse rate of 70 beats per minute. So what is double of 70? 70 times 2 is 140. So which of these exercises show a pulse rate of 140? Double would mean 140 beats per minute. So which one is it? You can see that for skipping, it is exactly at the 140 mark here. So the answer is skipping, yeah, which is A. So that is your answer. Okay, so boys and girls, today what we have learned is how to set up an experiment. So first of all, you come up with a hypothesis, which is like a prediction about what you expect the results of the experiment will be. It's in a form of a statement. It's like a prediction, but you call it a hypothesis. And you have learned that in order to make a very fair test, you need to only change one variable or one condition. In this case, for the experiment, we change the mass of the frog, and we keep all the other conditions the same. We call it the other variables are kept the same, such as the starting point, the size of the frogs, and the strength of the breath to blow the frogs. So I hope that you have learned how to be scientific, how to do a science experiment. And if you want to learn how to fold the paper frogs, stay on, continue to watch the video, and I'll show you how to fold the paper frog. I'm going to teach you how to fold a paper frog, do an origami of a paper frog. So you get a piece of paper. Actually, you need it to be in the form of a square. But if you don't have a square paper, what you can do is you can just fold it into a triangle. Okay. And then you tear out this piece. Tear out this piece, okay? Tear out this piece like that. So you have a square. And then you fold like that. So you have two creases here, like an X, right? The next step you do is you turn over and fold it like that. Okay, So you see where your creases are, and you can make a little tent. Make a tent like that. Alright. Next, we're going to make the 4 limbs, the front limbs of the paper frog. So you go like this. Anytime you can pause the video to work on your paper frog. Okay, like that. For another fold, like that. Okay, then you take these two. Okay, so you were like this, you fold it once. Now you take this part as well, you hold it and you fold it back. Similarly, you do the same with the other one. So your 4 limbs are done, and now you turn it around to make the hind legs. Okay. So you fold it like this. Do the same with the other. And now fold another time. So you get this, and what you need to do now is to fold this part so it helps to work against the edge of the table, and you fold it down like that. Okay, so it helps you to make the first fold. Then here I like to grab the middle and fold the second fold, and your paper frog's done. How about this one? Okay, so that's how you make a paper frog.